All right, so seems very difficult, but after explaining some key terms, it'll be easier to solve because this problem more looks more complicated than it is to solve it. So, whenever you see problems like this, there's something that we always should try to remember, and this is the word. Let's see, the word is PEMDAS. So let me write it over here because to me, this word here, PEMDAS, is the foundation of maths. It's what math is about. If you don't know these acronyms, you will never be able to solve. Well, it's not a complex problem. It looks like a complex problem, but if you don't know this word, you'll not be able to solve it. So, what is PEMDAS? So, let's talk about PEMDAS before we solve this problem because it will, I promise you, this acronym will open your mind to math because I don't know why we don't spend much time learning PEMDAS. We should invest a lot of time learning PEMDAS because it's the rule of math. This is the foundation. This is where math was founded. So the P stands for parenthesis. And look at this problem. We have no parenthesis. So there's nothing to do within the parentheses. Now, exponent. The exponent, the letter E stands for exponent, and it's a number that has an exponent over here, a number. So as you see here in this problem, we have 7, right? Is the base. So it's the N stands for base, and the X will be the exponent. All right, so you see here we have base and we have the exponent over here. And now multiplication and division. Multiplication and division, a lot of people get confused with multiplication and division. These are interchangeable. This can also be DM. So also PEMDAS is just an acronym for us to remember it, easier to pronounce the pronunciation, but it can also look like this. PEMDAS can look like this. This is one way PEMDAS can look like. It can also look like this. It can also look like this, or it can also look like this, right? So the only things that don't change is the E, the P and the E, right? Because we always look for parentheses and see what we can do within the parentheses. We always see exponents. If there's something to solve with exponents, we always do those things first before doing multiplication and division because what happens with multiplication, division, addition, and subtraction is that multiplication and division, whatever comes first, we solve first. If division comes first, in this case, if we see a problem that division comes first, then we solve division, and then we solve multiplication. And if we see a problem that where after solving for multiplication and division, we see it like this, subtraction, addition. Well, you solve subtraction first, then you solve addition. I hope you are understanding these things. Now that you understand PEMDAS, let's look at this problem. Let's see how we can solve this problem because with PEMDAS, it opens our mind to how solve it easier in an easier way. All right, so let me clear my screen over here and right now with that we have some space to write. Let's look at this problem. This problem looks very complicated, but it's not. You'll see. All right, so we have 7 here and we have 1. Whenever you see a problem like this, we have to, what we need to do is to make the base. This is the base, right? So because now you see, I explained to you what was PEMDAS, right? And if you remember, we are dealing no parentheses, so we have exponents, right? And remember, this is an exponent. We have the base, and this is the exponent. We need to look for any exponents, and this problem is all about the exponent. So we have the base, and over here we have the exponent. Now, whenever we see a problem like this, because you will encounter a lot of problems that are very similar, you need to just take the same steps. Now, what happens here is that we need to, on this side, right? What you do on this side, you must do on the other side. So we want to have both sides to be 7. How can we do that? How can we do this? So we have 7 exponent 7x minus 1, and we want to make this side 7 as well. How can we do that? Is that even possible? Well, the 7, if we raise the 7 to the 0 power, right? So this is an exponent rule. That's what I'm saying. PEMDAS is magic. It's like magic. Without PEMDAS, you cannot solve any math problems. So this is an exponent rule that we must apply. 7 to the 0 power. Did you know that 7 to the 0 power, or raised to the 0 power, it always gives you 1? I could even write 100 or 1,000 to the 0 power. If you give me always 1, I could write a million, a billion, a trillion, a zillion, will always give me 1. So now that we have this two problems like this, what is the next step to take? Well, the next step that we should take is this one. Now with that we understand what was happening to the 7, right? Which was this one. Well, once the base of each side are the same, now it's time to exclude them, because that's the goal. Whenever we see problems like this, we want to make the two sides be the same. Now, when we get rid of these bases because they are the same, we simply write the exponents now. And in this case, because we are getting rid of this one over here, this one over here is basically 0. Right? So now as this is a simple equation that you see here, right? So what is the next step you need to do? Well, the next step is to add here. And if you do the opposite of subtraction is addition, you add over here. Now these will cancel and you will have 7x equal 1. Now, what is the next step? Well, we're trying to solve for x, right? We're trying to solve for this variable here. Well, this was the whole issue. This was the whole problem. This was the whole problem, trying to solve for this x. So now, if we are here, we're multiplying. So we need to do the opposite, which is to divide. And we divide over here. So our final answer for this problem, the final answer is simply x equal, because we isolated x, 1 over 7. And there you have it. Yeah, look complicated, but it was not complicated.